The diagram opposite shows a sheet of brown paper that is folded along the dotted lines to form an envelope. So here are the dotted lines that the sheet is folded along to fold an envelope. The dimensions are shown in centimetres. So from here to here 6 centimetres, from here to here 23 centimetres, here to here 17 centimetres, from here to here 13 centimetres, from here to here 33 centimetres, from here to here 4 centimetres, from here to here 19 centimetres, and from here to here 11.5 centimetres. Part 1. Find the total area of the figure shown. Part 2. What are the dimensions of the smallest rectangular sheet of paper from which the envelope can be cut? And Part 3. Determine the percentage of this rectangular sheet of paper that is wasted in making the envelope. So Part 1. Find the total area of the figure shown. So what we're going to do is divide the region into 3 rectangles. Rectangle 1, 2 and 3. So here we have rectangle 1, rectangle 2 and rectangle 3. And we're going to divide it into 2 trapeziums. Trapezium 4 and trapezium 5. So trapezium 4 and trapezium 5. So remember, a trapezium is a 4-sided shape with one set of parallel lines. So in trapezium at the top here, we see that these are the parallel lines going in the same direction, they'll never meet. And then the trapezium at the bottom here, these are the parallel lines going in the same direction, will never meet. So the area of number 1, which is a rectangle, is going to be length multiplied by width. So it's going to be 33 multiplied by 23, and 33 multiplied by 23 is 759. So the area of rectangle 1 is 759 centimetres squared. Next, the area of rectangle 2. So it's going to be 33 multiplied by 11.5. And 33 times 11.5 is 379.5 centimetres squared. The area of rectangle 3 is going to be 33 multiplied by 13, which gives us 429 centimetres squared. Next, we want to figure out the areas of the trapeziums. So for a trapezium with parallel sides A and B and H as its perpendicular distance between the sides, we get the formula area equals A plus B divided by 2 multiplied by H. So here's an example of a trapezium. So the A and the B are the parallel sides, and the H is the distance between them, the perpendicular distance. So if we have a look at our trapezium at the top here, the A and the B is going to be 17 and 23, and the perpendicular distance between them is going to be 6. So it's going to be 23 plus 17 divided by 2 multiplied by 6, which is 120. Or you could say a half times 23 plus 17 times 6, which is the same thing. And then for the trapezium at the bottom, the A and the B, the parallel sides, are going to be 19 and 23. And the perpendicular height is going to be 4. So it's going to be 23 plus 19 divided by 2 multiplied by 4, or else a half times 23 plus 19 times 4, which is 84. So we have 759, 379.5, 429, 120, and 84. And adding them all together, we get 1771.5 centimetres squared. So part 2. What are the dimensions of the smallest rectangular sheet of paper from which the envelope can be cut? So the dimensions of the smallest rectangular sheet of paper from which the envelope can be cut are 11.5 plus 23 plus 13. So we've got 11.5 plus 23 plus 13. which give us 47.5, and 6 plus 33 plus 4, so 6 plus 33 plus 4, which give us 43. So that is 47.5 centimetres and 43 centimetres. Part 3. Determine the percentage of this rectangular sheet of paper that is wasted in making the envelope. So the area of the rectangular sheet of paper that we can use to make the envelope is going to be 47.5 multiplied by 43, and 47.5 multiplied by 43 is 2042.5 centimetres squared. So the waste is going to be the area of the rectangular sheet of paper minus the area of the actual envelope, which we got in part 1 to be 1771.5, and 2042.5 minus 1771.5 is 271 centimetres squared. So the percentage waste is going to be 271 divided by 2042.5 multiplied by 100%, or just multiplied by 100, which is going to be 13.27%. So we put the 271 over the total area of the rectangle, which we got to be 2042.5, and then we multiplied by 100 or by 100%.